Hi guys, welcome back to my channel. So today we are going to discuss another topic. So we have been doing HTML5 for a couple of days now. So I have decided to change the topic for a bit. So today we are going to do a topic of physics, that is kinematics. So let us start with it. So at first, what is kinematics? So let us learn something about kinematics. So what is kinematics? Kinematics is actually the branch of classical mechanics that describes the motion of points, objects, and systems of groups of objects without reference to the causes of motion. The study of kinematics is often referred to as the geometry of motion. So the kinematics actually means about motion. So in kinematics is, we can also define kinematics as kinematics is a branch of mechanics dealing with the study of motion of particles without taking into account of the forces and energy involved. So how many types of motions are there? There is one of the motions that we can see is random motion. So what is random motion? In this type of motion, the particles move randomly. That is, they do not move along a definite path. Example, the movement of dust particles in wind or in air. So this is actually random motion. Now, what is translational motion? In this type of motion, every particle of the body has the same displacement. Translational motion can be along a straight line, or it can be like along a curved path. The motion along a straight line is called rectilinear motion, and the motion along a curved path is known as curvilinear motion. So another type of motion is that rotational motion. So what is rotational motion? If the particles of the body revolve in a circle about the same axis, then the motion is said to be rotational motion. For example, the motion could be the motion of, let's say, of the motion could be the rotation of earth, right? So we can also define the rotation of earth as the rotational motion, or it can be also the merry-go-round, right? Merry-go-round always moves in a rotational motion, and it can also be a rotation of fan. Okay, so there are so we have learned about random motion, translational motion, and rotational motion. So I'm just writing about rotation of fan. So these are, what are these? These are actually examples of rotational motion. Okay, these are examples of rotational motions, and there are actually plenty of examples of this type of motion. So next we are going to learn about something known as oscillatory or vibratory motion. So oscillatory motion is a to or fro motion about a fixed point. Is so it is like, I can also define oscillatory motion. So examples of oscillatory motion can be like the motion of a pendulum, right? So pendulum can be defined as can be the example of a oscillatory or vibratory motion, what we call it. And it is very like a common example that we know, we have learned in classes. So another example can be like the string, when the string of a guitar is plucked, it actually performs an oscillatory motion. So now we are going to learn about the most common topic of motion, that is the displacement. So let us know what is displacement. So let's say we are just defining it. Displacement, right? So we are just defining it. We can just define displacement like this. The magnitude of displacement is actually the length of the shortest path from initial to final position. So let's say I have this position, that is x1, and I am like traveling, I'm in motion, and I'm just traveling from here to here and here. So let's say this is x2, So this whole thing, that my whole path where I just traveled, so this is actually distance, and the shortest path possible to reach my final position, that is x2, is actually displacement. Okay, so we can just define it like that: a change from one position x1, a change from one position x1. So our initial position was actually x1. X1, it changed from one position x1 to another position x2 is called a displacement. Called a displacement, that is delta x. So we can just write it like that: delta x is equals to x2 minus x1. So this is actually displacement. So the symbol, so this symbol is actually Greek uppercase delta. This is the Greek uppercase delta. So this is the Greek uppercase delta, and this actually represents a change in a quantity, and it means the final value of that quantity minus the initial value. Okay, so displacement and distance, there is a huge difference between them. The huge difference is that displacement, sorry, I'm just going to write it, displacement is a vector quantity. So I'm going to talk about vectors now. But before that, I'm going to write something about distance. Distance is actually a scalar quantity. Distance is a scalar quantity. Okay. So what is vector and what is scalar? So vectors are physical quantities that can be defined only if it's both magnitude and direction are specified. So it can be the example of vectors. So there are many kind of vectors. So examples of vectors, we can give many type of examples. Like we have learned already one, that is, let's say, displacement. Okay. And we can write also velocity. We can also write force. Okay, so now you may have a question that why displacement is a vector. So let us again draw our x1 point, and I'm going to again like draw a distance, and this will be our final point. So now I'm just going to draw a line like this. So this is actually the shortest path possible. So this whole thing is actually distance, and this, only this, is actually the displacement. So what is so what here you can look that this whole length is the magnitude, and there is a direction also. So we have known that from the definition of vectors, that physical quantities that can be defined if it's both magnitude and direction are specified, then they can be called as vector. So we can call displacement as vector because it has a magnitude, that is the length here, and it has a direction, that is this side. So we can write, so we write displacement like this in the form of S, and we just give a arrow over it like this. So all vectors quantities like say velocity also have arrow over it, force also have a arrow over it. So this help us to distinguish between scalar quantities and vector quantities. So let us now know something about the scalar quantities. So scalar quantities are physical quantities that can be defined only if its magnitude is only known. So examples can be examples of scalar quantities can be like, example of scalar quantities can be like distance. We can also write speed, because after all distance doesn't have any direction. Distance only has magnitude, but displacement have some direction. So like Mach doesn't have a direction, it only has magnitude. So these are some of the examples of scalar quantities. Okay, so we have learned about displacement, we have learned something about scalars and vectors. Okay, so now we are going to learn about another physical quantity, that is speed. So speed is the rate of distance traveled. So we can write speed as speed is equals to distance by time. So we write distance as d and time as t. So this speed is actually a scalar quantity. So in some books, distance is also written as s without an arrow over it. So we can also write as s by t. So you may have noticed that in displacement we give it an arrow, but in case of speed we doesn't give any type of arrow because it is a scalar quantity. So speed, in case of distance, we also don't give any type of arrow because it is also a scalar quantity. So now we are going to learn about another topic, that is another thing, that is average speed. So what is average speed? Average speed is the ratio of the total distance to the total time taken. So we can write average speed like this, average as total distance divided by total time. Okay, so let's say I'm just going to draw a graph to explain this to you. So the graph will be like this. Okay, so let's just say an object just traveled like this, okay. So this is actually a distance time graph, means in this case the speed is much higher than this case. So it again travel like this, and in it travel like this, okay, and at last travel like this. Okay, so I have just drawn this. Now what I'm gonna do is that I'm just gonna make some dotted lines, and let this be T1 and this be X1, And again, I am going to draw dotted lines from this point, and this will be T2, and this will be X2. Okay. So after that, I'm going to draw another line here. So X is actually the distance here, and T is the time here. As this is the distance time graph, we take time in the x-axis and distance in the y-axis. So this one is the last one, that is T4, and this one is X. Okay, so the average speed, we have just defined about average speed. So average speed is the ratio of the total displacement by the total time interval. So we can write like S average speed will be like x1 plus x2 plus x3 plus x4. Okay, and this divided by total time, that is t1 plus t2 plus t3 plus t4. So we have just defined about average speed. Okay, so this is the formal definition of average speed. So now we are going to learn about something known as instantaneous speed. So instantaneous speed is the speed of a particle at a given instant. It is actually defined as the ratio of the distance traveled in an extremely small interval of time tending to zero. Okay, so we can write instantaneous speed or speed like this. S is equals to limit delta t tends to 0, delta x, delta t is equals to dx dt. Okay, so this is actually instantaneous velocity. This actually means that when the delta t, that is the time interval or change in time, tends to 0, then the speed is known, at that time the speed is known as instantaneous speed. So we have learned about the instantaneous speed, we've learned about average speed, and after that we are going to learn about uniform speed. So what is uniform speed? A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time. So let's say an body just covers, so I'm again going to draw a graph. So I'm going to draw the graph like this. So this is again, as usual, we have taken the distance time graph. So let's say I'm writing here, I'm just marking some points here. So as usual, time is taken in the x-axis. So let's say this one is T1, T2, and T3. And this one, let's say x1, x2, and this one is x3. Okay, so I'm again going to make some dotted lines. Okay, so I've made some dotted lines like this. Okay, so this actually means that in a time interval of t2 minus t1, it covers a distance of x2 minus x1. Okay, so similarly, we are again taking this. So this and this are actually equal. Okay, so so here also we can take the same example like that. So we can find theoretically that if this is a straight line, if the graph is an inclined straight line, then the object is actually moving with a uniform velocity. Means, let's say the object is moving the speed of like 40 kilometer per hour. That means for every 1 hour, it is covering 40 kilometers. Okay. So we mean this like for every 1 hour, it is covering 40 kilometers. Now we are going to learn about variable speed. If body has variable speed, if it does not cover equal distances in equal intervals of time. For example, a train while departing from railway station increases its speed gradually. That means it is moving with variable speed. Okay, guys. So today up to this, in the next class, we'll learn about some one of the components of kinematics, that is like velocity, acceleration, and we will also learn about some graphs. So if you like this video, please like, share, and comment on this video, and please subscribe my channel and click on the bell icon to get notified when I upload a new video. Thank you.